The PAQi, Picture Acquisition and Inspection. How did we get here? LM3 Technologies and its founder, Michael Walt, have been in the machine vision business for over 20 years. Michael developed his first configurable vision system in the early 2000s, when the technology was first emerging as a reliable form of visual inspection. After years of experience with complex vision applications, LM3 set out on a challenge to make machine vision less time-consuming, more reliable, and more affordable. Traditional machine vision has its limits. If for nothing else, it requires a huge amount of time-consuming trial and error by machine vision experts to piece together several small inspection steps and tune their parameters to achieve the goal. Large vision system suppliers provide higher-level tools to package a set of steps to achieve a high level of accuracy across a common set of applications. But those tools are targeted at the mass market and do not always achieve the best results, thus requiring customization. PAQi is LM3's answer to the challenge because it utilizes artificial intelligence to replace the human function of first piecing together and customizing the steps to formulate the best inspection algorithm, and then uses the amazing processing power of today's TPUs, GPUs, and CPUs, and chipsets to fine-tune the parameters associated with those steps to achieve the best results while continuously testing better ways to achieve the goal in seconds versus days, weeks, or months. The rule of thumb we use is, if a human can see objects or defects on an image, the PAQi system will learn how to find the object or defects by simply providing it samples to learn from. Because the detectors LM3 deploys are non-proprietary, we can offer this technology at an affordable price, allowing smaller companies to compete with their larger competitors regarding quality control. Coupled with our low-cost hardware, AI-based visual inspection is no longer cost-prohibitive and ready for use by all. PAQi is a full-featured vision inspection system that incorporates proprietary software with high-resolution industrial cameras to achieve a customizable interface to your equipment and devices. What can it do? PAQi inspects manufactured or assembled components in an industrial environment. It stores pictures of components for future evidence and documentation, detects parts presence such as screws in an assembly, detects cosmetic defects such as scratches and dents, detects injection molding defects such as short, flash, splay, sink, jetting, and distortion. It also detects metal welds, such as burn-through, and it detects production equipment anomalies, such as debris and mold cavity. And finally, it detects alignment issues in assemblies. Here, the initial setup can be achieved within minutes. The first step in the process is acquiring images of your manufactured component. Once images are acquired, they are processed through the LM3 provided labeling software. After labeling, the image are then fed into an online training tool called QC Hero using AI-based detectors that generate a trained detector capable of correctly identifying the labeled objects or images. The trained detector is copied to PAQi, and a single button calibration is used to associate the detected objects with the expected objects in the images. This determines pass or fail. PAQi then operates on the line to do automated inspection. Here we can see a chart of how PAQi compares to things such as human inspection, sensor-based inspection, traditional machine vision. PAQi is being used by very big and small American businesses, such as Cooper Standard, Magna, Lear Corporation, Yinfeng, Bayer, Steelcase, CK Technologies, Cascade Engineering, and AGS Technology. The system costs are simple. A 10 megapixel single camera starts as low as $5,500 with quantity discounts possible. Additional industrial cameras, up to 6 total, can be added to the system for just $750 each. Because the PAQi can do image acquisition using any direct show camera, an inexpensive webcam can be used to reliably acquire images. Industrial types of camera run at less than $150 each. Using PAQi to do physical measurements require a one-time NI-VBAI license, which runs at approximately $850. QC Hero for detector training is a pay-per-use web-based system at $20 an hour. A complex object detector usually trains in less than 3 hours or $60 per training session. LM3 can be hired to do system customization. LM3 also provides affordable accessories including lighting controllers, I/O, breakout, boxes and cables, buttons, and LEDs to round out the system and avoid the need for high-cost integration. Please contact sales at lm3tech.com or call 312-376-8305 to receive a quote for your application or to receive a demo unit. Enabling inspection includes the PAQi controller, which interfaces with station, acquires and stores images, hosts inference models, and calibrates program codes for what is expected. There's also Label IMG LM3, which manually labels image, automatically labels image, uploads images, and crops images, as well as augments images. QC Hero manages image datasets, trains classifiers, and trains object detectors, evaluating models. The main components inside the PAQi include Intel NUC Windows 10 Pro version with solid-state M2 internal hard drive and up to 32 gigabytes of RAM. National Instrument image processing software called VBAI, Vision Builder Automated Inspection, allows a setup to inspect parts and pass or reject using the machine vision. Outside of the PAQi, we can see 2 high-speed USB 3 ports, RJ45 LAN ports, HDMI video monitor port, a lit power button, an external power supply port, external fuse, and M12 digital I/O port, as well as 2 high-speed USB 3. LAN ports allow connectivity to plant network to store info, transmit failure information, external porting capability, and communication to MES via Modbus TCP. There's also a lit on and off, which indicates power status at a glance, and fuse-protected internal components. Digital I/O can run stack lighting for visibility or other outputs to external devices and receive sensor signals to trigger the cycle. External power supply allows the PAQi to be low voltage DC, allowing multiple country AC voltage input, meaning internationally and within the US. Video output ports allows connection of monitor to display failures, status, detection information, program setup, and change screen. The digital input allows cycle start, part presence sensors, and light curtain input. USB ports allow connection to mouse, keyboard, scanner, printer, etc. The PAQi can also be connected to both Wi-Fi and Bluetooth support. Here, this diagram shows the different types of integration possible with the PAQi, including industrial communications with a station PLC or the use of the onboard PLC for digital I/O operations. Regarding its history, the PAQi was created in 2017, with its first goal was to have a camera device or system that, when triggered, would simply take a photo and save the photos to a file locally or or over the network. The second goal was to link the photo to the product for traceability. This was initially designed to be triggered by the scan of the product's serial number, resulting in an image stored by that serial number. The purpose was to have traceability pictures for the customer as proof of assembly and assistant in problem solving. Many other cases were similar, and the pictures are named by unique serial number, commonly referred to as warranty photos. The third goal was to have a unit which could break the price barrier of traditional systems. Current vision systems are expensive, and by reducing the cost of hardware, customers can deploy machine vision analysis across a wider range of applications, leading to a quality control standard. The system would have to be simple and low cost in such a way that if there was a failure, it would be quicker to unplug the unit, install a new unit with the program, and be back in production very quickly. The system would have to be able to handle multiple cameras. It would also have to connect to a robot and be moved. The system would have to be able to change parameters and programs of the camera on the fly. Finally, the system would have to provide easy-to-use configuration tools to avoid consuming plant personnel's time, which is better spent on production. The PAQi Functionality Overview 1, which is the simplest function, is for PAQi to take photos and store them to a file. The PAQi waits at the start position for a trigger, and once received, it scans the barcode of the part being inspected, which then requires an image, and stores it to the network or locally, and records the results to the station. Another function is for the PAQi to take photos, analyze them, and store them to a file. The analyzing is accomplished through National Instruments and VBA software, which processes the image to the criteria that it has been set up. The NI screen below shows the example where 3 distinct regions are present. If the region are white or black, then the cap is missing and the NI software fails the image. Notice the large ROI along the bottom. It's looking for the bottle. The bottle is allowed to move in that region, and the cap ROI also moves with the location, which allows processing even if the bottle is not in the exact location. Rotation of a part can also be set up if needed. The function for the PAQi, which takes photos and analyzes them and stores them to the file and outputs information, utilizes a licensed version of VBAI loaded into the PAQi. Utilizing this software, or the AI-based setup by anyone in the PAQi is used to take photos, analyze them, and store them to a file and output information. This utilizes a licensed version of VBAI loaded into the PAQi. Utilizing the VBA software or our AI-based detector training using QC Hero, the user can set up the areas of interest to be inspected. The regions can be set up by anyone, internally or externally. The analysis is done from multiple images. This is where lighting and resolution are important for the user to develop a repeatable photo that highlights the components or areas that need to be evaluated. This may also involve using different light color patterns or options, as well as UV or IR lighting. NI offers many tools to evaluate images, including color intensity, the intensity, particle detection, etc. This allows the analysis to be robust. Using AI-based inspection provides a machine learning-based means to do object and defect detection and classification. Since the PAQi has multiple camera capabilities, it can take warranty pictures with some cameras and analyze pictures from other cameras. There are cases installed where 2 cameras are taking warranty pictures and 2 cameras are taking pictures and analyzing them. The different combinations are up to the user to configure. Areas that need lighting control are enclosed to prevent ambient light from affecting the image. In some cases, it makes more sense to mount a camera to a robot, especially if they are larger parts and you want to get very close-up pictures of different sections of the part. This slide explains how that interaction works. The latest version of the PAQi operational software provides a means for job scheduling to stop molding production when PAQi counts the number of good parts equal to what is scheduled. In production count mode, the PAQi senses when the cycle time a production exceeds expected cycle time and requires the operator to select a reason for the downtime, which allows us to track downtime across the entire job and report OEE metrics. Under all circumstances, PAQi stores results to a SQL server, whether it be a local one or one on your network. All individual step results, whether it be from VBI measurements or detectors, are stored by their score or their measurement value in reference to the image that was taken. This allows for more advanced analysis of production performance. PAQi is used for a multitude of inspection requirements, including feature presence, defect detection, color classification, physical measurements, and traditional machine vision operation, and a combination of object detection and classification, as well as object detection and object measurement. Additionally, PAQi can be used to control the entire station or be subordinate to the station's main controller. Finally, parts can be loosely or not all fixtured due to PAQi's ability to do object detection anywhere in the field of view, even with inconsistent lighting. This functionality is powered by artificial intelligence such that a detector or detectors are trained using QC Hero to do object detection of any object in the field view, including defective objects or classification, which involves categorizing the entire image in order to determine if it meets the inspection requirements. QC Hero provides a mean for continuous improvement in detector management. Using this tool and the configurations tools available in PAQi, the system can be completely managed by your personnel with little or no vision system expertise. Simply label the object you want to detect in a set of images or categorize the entire image in the case of classification, upload, and train to create a detector. Keep in mind that QC can learn even the most subtle differences in good versus bad, and if the differences are visible. We're showing defect detection molded parts, and this molded part is approximately 24 by 24 inches, which is rather large. And we are inspecting for defects with a 5 megapixel camera. So this is a 2-cavity mold. It inspects the left side, the right side, and the lower side, and the top side, and here we can see that it's a good part. In this image, there's a large short, which most likely happened during the startup of the press, which is quite easy to detect. Smaller defects, such as this little short, which can be seen on the right side here, are also caught by PAQi. In addition, it can detect splay. Advantages over other systems is that one camera can be used to inspect the entire part versus small regions of the part. Traditional systems are unable to detect variable defects well because configuration is required by defect type. No special lighting is required. It's able to keep up with production line due to the ability to take one image of each cavity and analyze the image once. It also has one trained detector across multiple molding machines running the same part. One trained detector can be used for object detection on the same part of different colors. It has multiple detectors which can be used for varying degrees of defects. Detectors can be continuously trained on new images to improve its accuracy over time. And the mounting of camera is less arduous because the camera can be positioned several feet from the part, and the cost of the system is significantly less than traditional systems that would require up to 10 smart cameras at $2,500 per camera plus integration. The next use case is parts presence for hog rings. Detecting the 5 hog rings to hold cover over airbag bolster. Notice the black material on this bolster. Knowing that the 5 hog rings are in its place is essential in the airbag working. Here we can see that the PAQi recognizes the hog rings even on a lighter color, compared to previously when it was on a darker color. We are also able to mount a single camera. While the overhead lighting structure is used to make sure it is out of the way of a sliding torque tool that is used to fasten the airbag to console frame. After the operator fastens the cover to the frame, as shown in the above sequence, where eventually the operator inserts the 5 hog rings to complete the operation. The advantage over other systems in correlation to hog rings and detecting them, the PAQi only uses 1 camera and it can be used at a long distance from the part. In traditional systems, they're unable to detect small silver objects on a white background, and the PAQi can do that. 1 train detector can be used for the left and the right side, as well as 2 different assembly fixtures with slight differences in camera angle and fixturing. There's no special lighting needed, and the cost of the system is significantly less. Multiple fasteners versus multiple objects of the same type. So this detector's been trained to stand screws, clips, brackets, bug screens on a very large grill. This grill is over 6 feet wide, and it's only using a 10 megapixel camera on the overhead structure, so that it's out of the way of the operator. Similarly to the other advantages, you can use 1 camera. The traditional systems are unable to detect small objects. The PAQi is able to detect the small objects anywhere in the field of view, regardless of its rotation or left to right positional differences. 1 train models can be used for the left and right side, as well as 2 different assembly fixtures, and there's no special lighting required. The cost of the system, again, is significantly less than any traditional system that would require up to 15 plus smart cameras at $2,500 per camera. In this case, we're doing something similar again, with parts presence, push pins, but in this case, it is black push pins on a black substrate, which are detecting several of these 7mm push pins on both the left and the right hand side of the part. Here we can see the right side of the bumper, and in this we can see that the color of the substrate is white and the PAQi is still able to detect it. Also detects missing push pins even when there's a worker in the area distorting the background image. Use case 5, defect detection of metal welds. Here we can see the left side robotic weld inspection, which is good, and it detects the weld. Here we can see that the PAQi detects the reworked weld on the right side. Here the PAQi has detected burnout. The advantage over other systems in relation to the metal welds is that no special lighting is required. Fixture contains an adjustable overhead light, so we trained on the high and low settings to allow for reliable inspection for each setting. Because high focal point lenses can be used with our cameras, the cameras can be mounted in a position out of the operator's working area. Traditional vision systems not capable of detecting welds with a high degree of variance. While a traditional system may be programmed to detect large burnouts using black pixel counting, smaller burnouts and pitting cannot be reliably detected. 1 model can be used for defect detection. on the left and right side weld, as well as welds produced by multiple robots and human welders. Model can be continuously trained to be more accurate over time without the need for an expert vision system engineer. This is the use for PAQi on a GP12 station, which involves both parts presence and defect detection. Here, PAQi controls the entire station and there are 3 total cameras. As discussed earlier, PAQi allows things to be connected to it, such as sensors and lights. Here we have the PLC I/O, which can be broken out to provide M12 quick connections to sensors, solenoids, and LEDs. A subordinate PLC is used for lighting control, including the ability to dim the camera headlight using analog control. Here we can see a 10 megapixel camera head looking at the end of 8 parts with integrated lighting is mounted to the extrusion framework to allow for adjustments for different part types, which can be very beneficial. Here we can see the actual images of the GP12 running. We detect the presence of black foam on a black substrate, the presence and location of the datum clip, which is the image on the right, and the presence of a small piece of black foam stuck on top of the longer piece of foam. Here we can notice the ability to detect when the foam is present but still damaged. The trained operator at the GP12 station uses an interface. The PAQi system allows operators to override failures detected by the PAQi. The PAQi detector can be trained for a high degree of sensitivity to alert the operator to only verify features with low scores, thus reducing the time to reliably inspect multiple parts at once. So it's a time saver as well. Because of PAQi's precision in storing the results of each inspection, measurement values, and defective objects detected to a SQL database, queries can be written against the database to report the results over a date range. The GP12 parts presence and defect detection saves money in the following ways. Reduction in the number of human inspectors required for safe launch because the system can inspect multiple parts at once in seconds. It reduces inspection time, which reduces the number of operators and the shop floor space required. It improves quality control to shorten the containment time during GB12 or other customer-required safe launches. It reduces or eliminates customer paybacks for out-of-spec parts. It reduces scrap by signaling when a production machine is running out of spec. It is up to 1/5 of the cost of non-comparable but competing vision systems. It reduces the time to launch and exists safe launch. It is a machine and it is capable of working 24/7 without fatigue, distraction, and without a salary. It also does not get sick, need a mask, or require social distancing. It gets smarter the more you teach it and can achieve a 6 Sigma level of quality control. It allows you to dedicate human resources to production tasks machines are not capable of doing. Lastly, we're going to go over parts presence and color classification. Here in this application, PAQi detects finished components in a shipping container and classifies the color of each component to compare to the expected list of components. If the components are placed in the box incorrectly or out of order, PAQi alerts the operator to make corrections to prevent the customer receiving components they did not order. Defect detection molded parts have more of an advantage than other systems because PAQi can be used to control the entire station using the onboard PLC to connect custom-built applications with the PAQi's core image acquisition and analysis software. It has the ability to find the parts regardless of their position in the box prior to color classification. Deep learning color classification is more accurate than traditional machine learning classifiers because not only does deep learning tune parameters as it learns, but it also tunes the underlying algorithm using the parameter. Color classifiers built on TensorFlow AutoML to optimize classifier construction prior to training. And deep learning color classifiers is trained using QC Hero LM3's online classifier training tool. Color classifier can be continuously trained to improve. VBAI can be used for edge finding, pattern and geometric matching, color inspection, and gauging. Golden template comparison, image segmentation, coordinate system, image filters, and frequency analysis. There's also image arithmetic and logic functions, spatial calibration, particle analysis, barcode reader and grader, which are measurement applications. That concludes our presentation of the PAQi. Feel free to contact sales at LM3.
I'm Mike Walt from LM3 Technologies. This is our PAQi system, which is used to do vision inspection of the molded parts using deep learning. Up top we have a camera that's looking at each part individually as it's moved by the robot. We have a user interface that details what is happening during the inspection process. Right now the machine's in a state where it's waiting for a new job. So I'm going to select a new job based on part number. We call this a PSSS. I enter the number of parts they're going to run, 1,000, hit enter. The machine starts in a startup mode. So normally when you're first starting up the machine, you're doing some fine tuning to produce good parts. When you're ready, you put it in a job running mode. You'll notice over here to the right, there's a green light that tells you you're in a running mode. And at that point, the machine is inspecting each part individually for defects and also keeping track of how many parts have been produced, notifying the operator of the machine when the box is full and when the job is complete as well. Additionally, we keep track of downtime. So if the machine delays for some reason, we ask for a reason code so that we can track any kind of down events for use in OEE as well. So as you're watching the machine, it's going through the inspection process, feeding back to the robot, pass or fail. When a part fails, it's dropped in the reject bin. When a part passes, it goes on the finished goods conveyor.